Dear students, myself Dr. Suvarna Kshirsagar, working as Dean Student Welfare and Assistant Professor in Physics at N.B. Navle, Sinhagad College of Engineering, Solapur. Today we are going to study fundamentals of laser. Laser is an acronym for light amplification by stimulated emission of radiation. So you might have seen the difference between laser light and normal light. It is very much amplified, intense, unidirectional beam of light which is different than the normal light. Why we will get such differences? Because this laser is also a artificially produced light. Then how such an intense beam is produced? What is the phenomenon or working behind this getting the laser, that we will see in this lecture. So there are mainly three important phenomena which are known as quantum mechanical phenomena depending on the laser works. First phenomenon is the stimulated absorption, second one is spontaneous emission, and third is stimulated emission. One by one we will see in detail. First process is stimulated absorption. Here in the figure you can see there are two energy states, E1 and E2, and an energy in the form of photon is incident in this state. So each and every material initially consisting of the atoms and molecules, and these atoms and molecules, they remains in the ground state. They prefer to remain in a minimum potential energy state, that is ground state. Here it is shown by E1. Unless and until we supply the external energy, they will not jump to the higher energy states. These higher energy states E2, E3 En are known as excited states. So if we will supply the energy externally in the form of photon, this photon is absorbed by the materials in the atoms and molecules in the energy state E1, and therefore their energy increases. If this energy h nu of the photon is such that it is the difference equal to E2 minus E1, then atoms will jump from lower energy state E1 to the E2. And we can say that the atom is excited, and this process, quantum mechanical process, is known as stimulated absorption. So we can define stimulated absorption as the process in which atoms or electrons in the ground state absorb the externally supplied energy, which is equal to the difference of energies E2 minus E1, and they get excited to the higher energy state. This process is known as absorption. This stimulated absorption takes place when number of atoms, which is also known as population of the energy state E1, is greater than E2. Suppose N1 is population of E1 and N2 is population of E2, then if N1 is very greater than N2, then only the stimulated absorption takes place. So whenever you will supply the external energy, and if atoms in the ground state are larger as compared to the atoms in excited state, stimulated absorption takes place. So this is the first quantum mechanical process that you have to understand. The second quantum mechanical process is spontaneous emission. So if by some means, due to supply of energy, atoms are present in excited state now you can see the difference between initial state, stimulated absorption, where the arrow is in upward direction, which indicates that transition was from lower energy state to the higher energy state, from downward to the upward. But in spontaneous emission, the word emission itself indicates that now the transition is downward and a photon is emitted in this transition, and the process is spontaneous. Here the word spontaneous tells us that this process is naturally occurring. This process is taking place on its own without supply of external energy. This is because atoms in the excited state, they cannot remain for longer time in excited state, because lifetime of excited state is in nanosecond, about 10 raised to minus 8 to 10 raised to minus 9 seconds. So this state has very low lifetime, and therefore such electrons are said to be unstable, and therefore again they will try to regain their original energy state to become a stable. And hence within the nanosecond, these atoms on their own, they will do the downward transition, and therefore in energy state E2 they have higher energy and even energy level is low. Whatever the difference E2 minus E1 is there, which is equal to h nu, is again given out in the form of photon, and which is known as emitted photon. So this emitted photon is emitted in this process, and therefore this process is known as spontaneous emission. So this is the process in which atoms decays from the level 2 to 1 through the emission of photon of energy h nu, which is E2 minus E1. And this process is completely random process. That is, it is naturally occurring. We are not supplying any energy from external, and therefore this process is said to be naturally occurring. Okay, and this is also very important while studying the lasers. The third quantum mechanical process is stimulated emission. The word again stimulated indicates that this is the emission process, of course, therefore downward process from higher energy level to the lower energy level, but it is in the presence of external energy h nu. So here again we need to supply external light energy or photon of energy h nu, which is equal to the difference E2 minus E1. So here we are doing the downward transition in the presence of this incident photon. This photon is said to be incident photon supplied externally. This incident photon, what it does? It triggers the atoms in the excited state to come down to the ground state before the spontaneous emission takes place. Because in the nanosecond, atoms in excited state, naturally they are coming down by the process of spontaneous emission. But this photon, which is supplied externally, helps or triggers atom in excited state to come down before spontaneous emission takes place. And such a process is known as stimulated emission process. So the atom which is doing transition from higher energy state to the lower energy state again gives out the excess of energy in the form of photon. So this photon is emitted photon, and one photon is h nu. It is not at all absorbed. It remains there in this medium. It only just, its role is to trigger, to bring the atom in excited state to the ground state. And therefore at the output you can say that there are two photons. One is incident photon and other is the emitted photon. And these two photons are same in nature or in all respect. In all respect, meaning is that their amplitudes are same, they are emitted in same direction, they have same state of vibration, they are coherent, meaning is that their phases are same, and therefore such emitted photons add in phase and therefore their amplitude is increased and hence the intensity is also increased. So because intensity is directly proportional to the square of amplitude. The same process in this figure we can see in detail. The initial figure shows atom before the stimulated emission takes place. Atom was present in the excited state. A photon is incident. This photon, what it does, it brings the atom to the ground state. It triggers, but it remains there in the environment, in the material itself. And this process takes place before the spontaneous emission takes place. Initially, you might be remembering in the stimulated absorption process, the incident photon is absorbed, totally absorbed by the atom in ground state. But in stimulated emission, this photon is not absorbed. So its role is like a catalyst only. It only triggers, brings the atom quickly to the ground state. And it remains there in the medium, and therefore at the output, after the stimulated emission takes place, you will get 2 photons and atom comes in the ground state. So from this figure you may understand that stimulated absorption is also important in order to get the stimulated emission. Atom must be present in the excited state before the stimulated emission takes place. Now we will see the difference between spontaneous emission and stimulated emission, and these are the characteristics. So spontaneous emission, whatever the photons they are emitted in any direction. They are not in same phase. They don't have same state of vibration. They don't have same wavelength, and therefore they doesn't give rise to the amplification. They do not add in phase to increase the intensity. But in the case of stimulated emission, the incident photon and emitted photon both are in having all the characteristics same. They are said to be same in all respect. Which are these characteristics? Now you can see here, they are emitted in same direction. They have same phase. They have same amplitude, and they are emitted in having same state of vibration. Therefore, they are monochromatic in nature. They are coherent, and therefore intensity is increased, and therefore we can get the amplification. So the characteristics of stimulated emission can be seen here. The stimulated photons have unique properties such that they are in phase with the incident photon. They have same wavelength as the incident photon and travel in same direction as the incident photon. And therefore, they add in phase and gives rise to a amplification of light. So, stimulated emission is the process which produces the amplification of light. Thank you.